Hey guys, this problem here, question 11, is an example of using a geometric probability distribution. So the problem says, according to Master Foods, the company that manufactures M&Ms, 12% of peanut M&Ms are brown, 15% are yellow, 12% are red, 23% are blue, 23% are orange, and 15% are green. You will randomly select peanut M&Ms from an extra large bag looking for a brown M&M. Round all the probabilities below to 4 decimal places, i.e. your answer should look like 0.1234, not a much longer answer, or 12.34%. So basically here we're using a geometric probability distribution, and this one for the most part we don't do too much changing into this sheet because we're going to be focusing on a brown candy for this problem. We need to change the probability of success to match the probability of getting a brown peanut M&M. In this case, because we have 12% of the peanut M&Ms are brown, we need to change this from 0.5 to 0.12 to match the 12% convert into a decimal. Alright, so now we have all of these values here. So the first question says, compute the probability that the first brown M&M is the 9th M&M. So this is an exact value, and we're going down to this row right here is the exact, and these ones are cumulative. So when it says is the 9th, it assumes that this is exactly the 9th M&M. So we look at 9 and we see it's 0.0432. which matches our answer that we got here. And this is just an example of what you would type into Excel if you did not have the Excel sheets. But as you see, the answers match. So this one says, compute the probability that the first brown M&M is the 9th or 10th. Now this one requires a little bit of an extra step beyond just what you see in the sheet. So here it says is 9 or 10, so it is exactly 9 and it could be exactly 10. So here we have the two values of 0.0432 for 9 and 0.0380 for 10. So if we pull out our graphing calculator again from last time, let's clear all that. So now if we add the probability of getting 9, which is 0.0432 plus the probability of 10, which is 0.0380, we get 0.0812. So we look to see if that matches with what we're supposed to be getting, and theirs is rounded slightly differently because they used Excel when they added their functions on both of them, and it ended up with this answer. So they're about the same. So if you enter either 0.0812 or 0.0811, both answers should be correct in the MyOpenMath. Anyway, the next one is saying to compute the probability that the first brown candy is among the first 9 M&M selection. So it says among the first 9, so that can be that it could be the first one, it could be the third one, it could be the 7th one. We don't know. All we know is that it's among the first 9. So in this case, we're going to go over to the cumulative column and see if the probability that it falls in within the first 9 is 0.6835. And again, this is here we've been using PDFs because they were exact values. Here we're using cumulative, which means we're using CDF. And yes, that answer matches with this answer right here. So we're all good to go. And the last question says, if every student in a large statistics class selects peanut M&Ms at random until they get a brown candy, on average, how many M&Ms will the students need to select? This one is basically very similar to calculating the expected value, or the expected mean. So if we scroll over on this side over here, we see EX, which represents our expected value or expected mean, and we get a value of 8.33 and just keeps going. This one says that we round to 2 decimal places for our answer, so 8.33 should be our answer, and this is the calculation that we use, which is 1 over p, and as we remember, p it represents the decimal version of that 12% of getting a brown M&M. And so we do 1 minus 0.12, which gave us 8.33, which is the same as this box right here of the expected value. I hope this video was helpful for you.